Hello. So today we will talk about Section 8. Section 8 is about the continuous distribution. Continuous distribution we take in the last section the types of discrete distributions. We will discuss in this section three types of distribution: the normal and the uniform and exponential. But our focus will be on normal distribution because it is the most used distribution you will have in your next years of study and in your real life. Okay, so so we start from the properties of the normal distribution. You have this curve. The first thing you notice is what? The symmetry. That the right side is the same as the left side. Then the second thing is how the mean and median and mode look like in normal distribution, as all set on the same line. It's known as with the bell-shaped curve, and if it is standard normal distribution, and we will know what that means next page. If it is a standard, the total curve, total area under the curve will be 1. So usually the symbol will be look like this: y, and this means distributed by. N means for normal distribution, and here are the parameters mu and sigma square. So if I give you 0 and 1, that means the standard normal distribution. If I give you other values, then it will be not the standard normal distribution. So usually in our process, the first examples will be just a number of examples, but after that you need to convert to the standard normal distribution. The converting using something called z-score, and z-score means how many standard deviation you are from the mean. The definition of it is not on you, but if it's okay if you have the knowledge. So we will have for example, we give you mu, for example, 5 and sigma 3, and say that x is less than 50, and find the probability of things that less than 50. So we do what? We'll get this 50 minus this mu, which is 5 or 3, and then you will get it. So you can transform to the standard, and after that you can get a value. Then this value you will search for on the table. So what is the table? Here is the table you will find. So if you remember from the previous videos, we did what? We have a function, and we will solve this function given an interval. The function of the normal distribution is very complicated, and it took very much time to solve it. So the solution was, you have a table, and you just have the value you will look for, and you substitute this value, and you get this value. This diagram looks like the map for your table. So we'll have here 0 at the half. That means that this is a standard normal distribution. And then it tells you that the x we mean here by in this table, this area. So x less than till 0, not all this area, just from the point mentioned till 0. So the first example you have is, he wants to find you probability of z less than 1.5. Here, if you check, assume the 0.5 is here. So the value we'll get from the table is 1.5 to 0. But you need all the values that less than 1.5, so you'll get here also the other half. You know this half is half, 0.5. So you will get here in this table, this is the hundredth, and this is the tenth. So you get here 1.5, you keep scrolling until you reach here, which is 4332 plus 5, you'll get 0.933. Okay, so this is the first example, and here's an illustration of it. Second example is finding z bigger than 1.17. We don't have the bigger, we have the less. So we say what? Okay, we will have half, which is the total half you will leave in, and then we will set what half minus the probability of less than. So if you got less than, you'll get from here to 0. But all this value, all this area is half. So you will get what? Half minus this probability, and you get the rest. Okay? So third example is about finding bigger than negative 66. So it's the same concept. You will find the value that's negative 66 till 0. So you'll search for the table of value. Negative doesn't matter. Negative or positive, it will be from the same distance from the 0. So you'll get negative 0.66 from the table, and you add half because you want everything that's bigger than negative 66. So from negative 66 till the rest, and you get the value. Okay, so the fourth example is a little different. He wants from what? Less than from 21 and bigger than negative 1.18. So first, you'll need to get what? You need to get negative 1.18, which is this area, and you get the value of 2.1, and then sum them. Okay, here it is from the table, and from the table, and you get. So the next one is trying to find negative 1.5 and bigger than negative 2. So you want what? You want this area. At each time, if you are confused, you can plot it. So you have this negative 2, and you have here 1.5. As it is 1.5 go till 0, it is bigger. So you subtract from 2 minus the 1.5, and you get the value. Okay. Now we have a different question here. That he says you that you have a normal distribution. You have a normal distribution variable with a mean 8 and standard deviation 1.5, and he asking about what is the probability of first weighing more than 4.5. That means what? X bigger than 4.5. So again, if you remember from above, I said what? Okay, how we can convert from 4.9, we can reach the value of z. So you subtract the mean, and then you divide over 1.5. So we'll get this value. And remember here, notice we have converted from x to the word z after we made the operation. So we have z bigger than negative 2.07. Then simply you will get in the table, and bigger means that it's a negative value. From the negative till the 0, you have the area, and you add half because you need the rest of the plotting. So get this value. So weighing less than 8.7, so I have x less than 0.7, and you convert, and then you get easily. Okay. Between, so the same concept, just you made the conversion. Okay. Here is also the same, just between the values. Here is the difference. Here is the point that have an idea. He asks about what? What is the weight where less than of it have 30%, which is mean 0.3. So we'll do what? You will go to the table, okay, and search for area that is near or exactly 0.3. So here is 0. Here. So you can pick this or can pick this. If you pick this, okay, also. But it's really obvious to choose this or this. So this is what 0.8, and the hundredths is what 4. So it's either 0.84 or 85. Okay. So we substitute here and says what? The less than. Okay. So here is just just a point. It means like what? What if the value is less than? If it is less than here, so it will be the 0.3 plus half. so it's not the right. Okay, so it is the negative because it has less value. So it's negative 0. Negative 84. Okay, so we have this, and we will substitute for x and say, okay, we want to find x, and then you get here the value 6.74. So this is the desired outcome. Okay, so part 2 is about exponential distribution. An exponential distribution is kind of continuous distribution you may find in your life. Okay, it has also some applications. So the function of x is given by what? Lambda times e to the power negative lambda x, where x is bigger than or equal to 0. The expected value is given by 1 over lambda, and the variance is 1 over lambda squared. So if you have an example, it says that, okay, you have exponential distribution. He tells you that you have exponential distribution with lambda 1 over 5. So find p x, where p x bigger than 3, expected value of x, and variance. So you'll do what? What is bigger than 3? 3 to the infinity. So we'll have substitute the function fifth times e to the power negative x over 5. You will do the integration. So the derivative of the exponent would go here. I'll divide. So fifth goes on with the derivative, and what's resides is the negative. And then you need to substitute the infinity and 3. So negative infinity is 0, and you have also the rest is negative 3, so you have the result, which is e to the power negative 3 over 5. The expected value is just you substitute 1 over 1 lambda, which is you get 5, and the same as for the variance. Okay, so this is for the exponential. The third part is uniform distribution, and uniform is given by f of x is given by 1 over p minus a, and the mu is given by p plus a over 2, and the variance is given by p minus a squared over 12. So if we have an example and say that, okay, you have an interval from negative 2 to 0.8, and ask it to find x less than 0.5 and expected value of x and variance of x. So we will substitute in the first one. We will get here, and we get what? Just substitute the values, and you have from negative 2 till 0.5, as he says that from less than 0.5. So you have, as you have interval, the start of interval is negative 2, so you have negative 2 till the point he asks, and do the integration. You will get the result, and so there is a negative 3 over 5. For mu, we'll substitute the rule. You have a plus b over 2, and you get this. Here is b negative minus a, and as a is negative, so it will be added. So you have, and then you do the square, so you have 7.84 over 12.